My name is Fatima Yassin, and our presentation is titled by Characterizing and Detecting Similar Users on Twitter. In this presentation, we will briefly introduce detecting similar users on Twitter, present some of the existing works in the field, then explain our methods, and finally show how we tested and evaluated our methods. Introduction. Lately, social networks have become a vital part of our lives. Among all social network medias, Twitter, a microblogging site, has become one of the most widespread platforms with a non-stop growing number of active users. Analyzing Twitter content has recently gained a lot of attention due to the significance of its content. Detecting similarity between users based on their produced content, behavior, interests, and activities is an important application of Twitter content analysis. Detecting similarity could be used in profiling users for security, recruitment, and social reasons. But before we proceed, we must emphasize that there is a difference between identifying similar users and recommending who to follow. A user may follow another one because he is interested in the latter's news and not necessarily similar. For example, a user interested in sport may follow Kobe Bryant, but this user is not necessarily similar to Kobe Bryant. In this project, in contrary to recommendation services, we are only concerned about detecting similar users that have similar profiles or produce content similar to each other. Signals for detecting similar users. Several measures, also called factors or signals, are used to find similar users on Twitter. The signals are following, follower, retweet, favorite, mention, and hashtag signals, in addition to the signals that are concerned about the contents of the tweets. These signals are used by several frameworks, as you will see, to compute the similarity between the examined user, for whom similar users are detected, and the candidate user, who is checked if similar for the examined user. Related works. The most famous and well-known service for detecting similar users and recommending them is the Who to Follow. They provided an embedded service that is dedicated to Twitter. Their formula depends mainly on the following relationship between two users. It exists a similarity metric that integrates four signals, which are mention, hashtag, URL, and URL domain. However, it has been proved that URL is a weak signal. Moreover, they are only concerned in detecting existing edges between users and neglecting their contents. As to the SVO framework, it relies on a sole signal, which is the hashtag signal. On the contrary, TSIM framework proposed a comprehensive framework that integrates seven different signals. However, the strength of these signals varies. Nevertheless, they didn't assign constant weights for these signals. They assumed that allowing users to dynamically change the weights of the used signals makes their framework flexible. But the question raised here, is a normal user able to choose the appropriate weights or able to distinguish weak signals from strong ones? Another issue is the normalization of the signals. They kept most of the signals unnormalized, which affect the output of the signals. Our objective is to design and evaluate a new predictive model that allows identifying similar users. In order to fulfill this goal, we proposed three new signals. The proposed methods. Following signal. The first characteristic that comes to mind when describing how two users are similar is by examining their following relationship and common users between them. In fact, Twitter is a directed graph. For this reason, we assume that when a user A follows another user B, this signifies that A is interested in what B tweets. However, we can't be certain that user B is interested in A just by being followed by A. For this reason, we are only concerned about the friends or followings relationship. Thus, the score of the candidate user is incremented each time a candidate user appears in the following list of the examined user. Top 10 topic signal. Logically, similar users must have similar tweets contents. We search for a content signal that provides us with a general overview of the user's tweets without the need to handle the large sizes of the tweet's documents. For this reason, we use the latent Dirichlet allocation to extract topics within the tweets coupled with the proportion of each topic found in a document. Then we apply the cosine similarity between the examined and candidate users' topics. Common friend signal. We considered that two users are similar if they follow the same accounts. For this reason, we counted the number of common users that both the candidate and examined user follow. Evaluations. In order to evaluate the signals, we got advantage from machine learning to perform our data analysis. But we needed first to prepare the feature file to be used in training the classifiers. Our dataset contains three examined users. For each of the examined users, we chose arbitrary candidate users. After all, our dataset contains 387 pairs. We crawled the required data for our signals computation as their tweets, friends' IDs, and followers' IDs. We implemented and computed the needed signals values containing TSIM's signal, SVO hashtag, and our signal. Finally, we classified each pair to either similar or non-similar depending on the profile interests and most of the tweets they have. This step is crucial because we are applying supervised classifiers. A well-labeled dataset provides a reference for the machine learning model to check its prediction and accuracy and refine its algorithm. Feature analysis, the statistical analysis. In order to analyze the strength of the signals, we made statistical and visual analysis of the features to show the relevance and correlation with the target variable. According to ANOVA, analysis of variance, our proposed signals are of the top 5 signals having significant high scores. We considered ANOVA since it's one of the most commonly used feature selection methods that are used to identify and select the input feature that are most relevant to the target variable. In addition, the Pearson's correlation analysis show high association between our three signals and the target variable named label. In fact, a correlation is considered as strong if the coefficient value lies between 0.5 and 1. The visual analysis. Another way to detect the features with greater effect is by plotting the different signals values to examine the separation of the two classes, similar and non-similar users. Yet again, our proposed signals allow to separate the dataset into two classes in a significant way. For example, the plot on the left belongs to the common friends signal. Obviously, the two classes are separated. However, the graph on the right, representing this same common interest signal, shows overlapping values. This makes their uses in any machine learning algorithm insignificant or lower the precision of the model in the validation. Training and validation. From the previous analysis, we detected the main signals which have the higher impacts on identifying similar users, which are the three signals we proposed, in addition to TSM followers and SVO hashtags. In order to prove the performance of our signals, we built several classifiers based on the well-known supervised algorithms, multi-layer perceptron neural network, support vector machines SVM, naive Bayes, and k-nearest neighbors KNN. Each classifier was trained and evaluated using three different methods or combinations of signals: TSM signals, SVO hashtags, and our three signals. We examined the precision for each classifier using the stratified 10-fold cross-validation method. The histogram shows the average precision of our three signals represented by blue bars as compared to TSM signals in orange bars and SVO hashtags in green bars. Our signals clearly perform better than TSM and SVO hashtags across all classifiers. The conclusion and future work. We proposed in this article a new method for the detection of similar Twitter users. This method is based on three measures or signals that integrate both the social graph and user profile contents. An important future improvement of our work would be to consider a data centered machine learning approach that allows to produce an ambiguous data set with less noises. Data labeling is one of the challenging steps in a supervised learning. In fact, the quality of labeling absolutely affects the accuracy of any machine learning model. Hence, an unsupervised learning may be considered to identify similar users, and then the labeling dilemma will be eliminated. Thank you.